Hey guys, Mr. Bowman here. In our video, we're looking at the Kuiper College 2023 2.4 Trig Practice Internal, and hopefully you remember the name, going over the White Rover camping grounds example that we just did in class. So the context of the question, the first bit of information that was really useful, 3.8 meters per square meter. So that means if you have the area of a shape, you'll be able to convert it to dollars using that rate. We've been told they've got a budget of $9,000 for rates, and we're looking to estimate their bill. So we need to, I'm assuming, find the area of whatever shape, and then find out what their bill will be as a result. So jumping over to task 1, which is the main bit of this question, for the achieved and merit stuff, use the dimensions in diagram 1. So we're not looking at diagram 2 yet. And we've been asked to find the area. And after that, we are looking at the cost to see if it is within their budget. So what I'm looking to do is I'm trying to find the area of the 3 triangles. So triangle number 1, triangle number 2, triangle number 3. I'm going to add them all together to find the area. So the only issue is we may or may not have the area for each of those shapes. So let's have a look into it. So we're going to start off down the bottom. We can see we've got triangle ABC down there. And we've got the angle with the 2 sides that join to make that angle. And that is enough to use the area rule to find the area. So straight away we can find the area of that small triangle. So what I've done, my step number 1, and notice I'm using some narrations. I'm going to say find area of triangle. I'm just going to draw a triangle A, B, C. And I know I'm just going to help by doing a bit of a sketch. So I find sketching each one works. That one there was 125. Down there was 38. And up here was 27. So I'm going to label my triangle. So that big angle there is going to be big A. Opposite to that is little a. We don't care about little a. And then B and C come together to form the last bit of this triangle. And my formula, just going to jot it down, area is going to be equal to 1/2 of BC times sine big A. I'm now going to substitute. So remember from our diagram, I know that big A was equal to 125 degrees. So I'm going to sub that in. B was 38. Again, I'm going to sub that in, and C was that 27. So C equals 27. So you'll see B, C, and A. I'm going to take out the letters and I'm going to put in the numbers that I know them to be. So carrying on, area is going to be equal to 1/2 times B, which is 38, times C, which is 27, and we're going to go times sin or sine 125. I'm now going to smash this bit here into my calculator. That's just a number. Make sure you're in the right mode. Make sure you're in degrees. If you put that into your calculator, I'm hoping you get 420.5 meters squared, and that had a 1 dp rounding. Gosh, sorry, I should just get rid of that 5. That was actually a 2 over there. So 420.2 meters squared. So important for this question as well. I've described what I'm doing, triangle ABC. I've stated my units, and I've stated my rounding. So those little things all must be there. If you miss those out, you might actually miss out on getting achieved. So we've done area. We've done this area here. The next triangle, the big one in the middle, is a bit more unusual because the angle I've got is here, which means I need this angle and, this side and this side to find the area of that shape. But the issue is I don't have side AC. So I need to figure out length AC before I can go ahead and find the area of that big triangle. So that's going to be my second step. So step number 2, I need to find, and I'm just going to write length AC. And we could deal with either triangle. We could use the big triangle to find out the side, or we could use the little triangle to find out that side. If you're not sure which one to do, pick the triangle with the most information, which is going to be the bottom one. Probably means it's going to be easier. So again, I'm going to sketch my little triangle. So there's my triangle. That there was 125. We had 27 and we had 38. and I'm trying to find that there. I'm going to call that x. So I'm dealing with three sides, so x, 38, and 27, and I've got one angle being 125. So the fact we've got three sides and one angle, that's telling me I should be thinking about the cosine rule for that. So I'm going to jot down my cosine rule, and again, this is on your formula sheet if you do forget it. So a squared will be equal to b squared plus c squared minus 2bc times cos a. So there's my formula. Labeling my triangle, I had big A over here, 125 degrees. I had little a over here, and B and C as the remaining ones. So based on this, my big A is 125. That was the degrees. My little a is going to be x. That's the side of the triangle I don't know. B will be equal to the 38. And then finally, C will be equal to that last side, 27. So I'm just doing this for illustrative purposes. You can jump straight to the substitution if you're feeling confident. So let's put all of these in. So a squared is going to become x squared. So we've got x squared is equal to b squared is going to become 38 squared because we've got 38 over there. 38 squared. C squared is going to become 27 squared. So we've got plus 27 squared. 2bc will be, so minus 2 times 38, which is the b, times 27, which is c, and we're going to multiply that by cos big A, and our big A is 125 degrees. So we've got cos 125. I'm now going to calculate, so x squared will be equal to, and all of this stuff here, I'm going to put into my calculator to let me figure out what that is. And when I do that, I got 3,349.9788. And I tried not to round too much at this stage because I didn't want to impact my final answer too much. I'm now going to square root, that's my final step, 3,349.9788, which tells me x is 57.88 meters. And that was a 2dp rounding. And again, I want to emphasize a few things. I've described what I'm calculating, length AC. I've stated my units, meters, and I've stated my rounding. You do need those three to guarantee sure up absolutely on your mark. So I've now got the length AC, which means, as I said before, I can go ahead using the angle 46, the two sides, I can go ahead and find the area of that big triangle. So let's go ahead and do that. So step 3, we're going to find the area. So again, I'm going to narrate what I'm doing. Find area of triangle DCA. And note, DCA comes from the letters that are on the corner of that shape. So let's sketch our triangle. So there's my triangle roughly. That there is 46. This side over here was 50, and the one we just calculated is now down the bottom, 57.88. So big A is the angle, which means little a is the other side, which we don't care about, and then B and C are the other two sides. So our formula, same as in step 1, area is equal to 1/2 of BC times sine A. I'm now going to substitute what I know, and just recapping, big A was the angle, which will be equal to 46. B is equal to one of the sides, which we've said as 50. And then C is the final side, 57.88. So C being equal to 57.88. I'm now going to sub them all in, so the B and C needs to go away, and the A needs to go away too, and that'll let me figure out the answer. So our area will be equal to 1/2 times 50 times 57.88 times sin 46. Forgive me as I write small because I'm running out of room. Once I've done that, I can then go ahead, put this lot into my calculator over here, and that will get me to 1040.9 meters squared, and that had a 1dp rounding again. And then again, the three things I want to emphasize: I've stated what I've calculated, I've got my units, and I've stated my rounding. Three really, really important bits to this question. So I've cleared all my working. On the diagram, you'll notice I've just updated for the three measurements from the first three steps. And my next job is to think about how can I calculate the area of this last side. And this one here is going to be a bit tricky because I don't have the side AE, and it does look like it's going to be quite challenging to calculate because the opposite side to the angle would be A for the cosine rule, and that's the side I'll calculate for. So that would be the B and the C side, and it's more difficult to calculate those sides. So it can't be that. So what I'm thinking here is I'm going to look to calculate side DA, and that should give me enough information to then hopefully find out one of the two remaining angles. And then I can think about perhaps a sine rule or some other rule to help me find the area or the last measurement I need for the area of this shape. So let's crack into DA. So that's step number 4 that we're going to do here. We're looking to find the length DA. And looking at the big triangle, I can actually find DA because it has the same side as the smaller triangle. So we're going to use the information from the big triangle. And I'm going to call that X. And again, I've got 3 sides and 1 angle. So that's telling me cosine rule. So I'll write 3S, 1A. That is my cue to use the cosine rule again. So I'm going to sketch my triangle to make sure I don't do any silly math errors on my way. So that angle was 46. That length there was 50. We had 57.88 down the bottom. And then we had X along the side there. And as I said, A squared is equal to B squared plus C squared minus 2BC times cos A. So let's label our sides. The angle is big A, which means the opposite side is little a, and the other two sides, B and C, doesn't matter which way around they are. So let's think about what we need to substitute. The angle, 46, is big A. So big A will be equal to 46. B will be equal to 57.88. B will be equal to 57.88. And then C will be equal to the 50. And I've actually forgotten about little a, but little a is going to be x because that's what we're trying to find out. So our little a will be equal to x. So let's sub them all into this equation. So our a squared will become x squared. So we've got x squared will be equal to b squared, which will be 57.88. 57.88 squared plus c squared, which will be 50 squared. And we've got minus 2 times b times c. So that's going to be 2 times 57.88 times 50. And then we've got times cos a. And that's going to be cos 46. So times cos 46. Big line of working there. All of that stuff there, we're going to put it in the bracket. We're going to see what x squared, so not put it in the bracket, put it in our calculator. We'll see what x squared comes to. And in this case, x squared will be equal to 1829.4117. X will therefore be equal to the square root of that number. And when you put that into your calculator, I'm hoping you get something along the lines of 42.77 meters. And that had a 2 dp rounding. And just highlighting my 3 things, I've described what I'm doing, I've got my units, and I've stated my rounding. Okay, we're now trying to think of our next step. And if you called this side here x, you might think, oh, I've got to use the cosine rule. So you've got the opposite side. So you've got 3 sides and the angle. But the issue here is x, as I said before, will be one of the b or the c values. And that won't work for us that well. So we need to come up with another plan. We can't call that x. So what I'm thinking here is we do have an opposite. And we've got this 40 over here, which would be opposite to this angle. So we could calculate this bottom angle here, which will then let us figure out this top angle here. And why I like that top angle is because I've got the side going to it there, and I've got the side going to it there, which means I can use my area formula to find the area of that last triangle. So hopefully that made sense. So we're now thinking of our pairs, and we're going to use the sine rule to help us out. So let's do that. So number 5, we're looking to find angle, and we call it angle EAD. So EAD representing the corners. EAD. And as I said before, we're looking to use the sine rule, but let's sketch our diagram so we can see clearly what we're doing. So this angle here was 63 degrees. That there was 40 meters. We had 42.77, and we're looking X to find that angle. So if 63 is big A, that means its opposite side, 42.77, is big or little a, and then down there is big angle, which means the 40 opposite to that must be B. So let's write our sine rule, and because we're finding the angle, notice I'm putting the angle part of it up the top here. So we've got sine B over B. We're now going to substitute. I won't write these all out separately, but we've got big A as 63. So that there will be sine 63 over little a, which is 42.77. And that there will be equal to big B, which is our X value. That's our unknown. So we've got sine X over little b, which we said was 40. Now we're going to do a bit of maths here, or a bit of algebra rather. This 40 is going to move to the other side as multiplication. So I'm going to have sine 63 over 42.77. So that's unchanged to above. I'm going to do times 40, which is the opposite to the divide by 40, and that will be equal to sine X. And carrying on over here, this is going to be where it's a bit annoying. X is going to be equal to sine -1 of all of that we've left over there. So that's sine 63 over 42.77 times 40. And be careful, make sure you've got the proper brackets in when you're doing this in your calculator. So X, when we put that on our calculator, comes to 56.44 degrees. And again, I've done a 2dp rounding. And just a reminder about our three things. I'm finding the angle. I've told or explained what I'm trying to solve. The degree sign is the units, and I've stated my rounding. So I've got those three things. Updated my diagram. I've now calculated that angle down the bottom, and I know the three angles in the triangle all have to add to 180, which means, so number 6, I'm looking to find the top angle, which is angle EDA. So find angle EDA, and I know that's going to be 180 minus the angle I just counted, minus the other angle we already knew. And that gets me to 60.56 degrees. And again, that was impacted by the 2dp rounding. So I've updated my previous measurement. Now that I've got that angle, I've also got 40 meters, and I've also got the other angle, or the other side here. That means I can go ahead and find the area of that triangle now. So step number 7 that we're looking at is we're looking to find the area, of triangle EDA. And again, I'm going to sketch my triangle, because I find if I sketch the triangle, I tend not to make mistakes. So there's 63. Oh, we actually don't need that measurement, do we? I've got the 60.56 up the top. I've got my 40, and I've got my 42.77. So I'm going to state my formula. The area is equal to 1/2 of BC times sine A. I know my angle is going to be big A, so A will be equal to 60.56. B can be either of those sides. We'll pick 40, and C would be the other side. So B is equal to 40, and C is equal to the remaining side. I'm now going to substitute, so my area will be equal to 1/2 times B, which is 40, times C, which is 42.77, and then finally times sin A, so that's sin 60.56. This area here, or this part of my question, I'm going to smash into my calculator, so my area from all of that comes to 744.9 meters squared, and that had a 1 dp rounding. And again, highlighting the three things, I've stated what I'm calculating, I've got my units, and I've stated my rounding as well. So now that I've done that, writing it in, this is the final piece of the puzzle. So we have, or using the wrong pen color, but our area of this portion is 744.9 meters squared. I've now got all three areas, 1, 2, and 3. So I'm going to add those three together to find the total area, and that's step number 8. So step number 8, find the total area. So total area will be equal to 744.9 plus 1040.9 plus 420.2. And putting all of that in my calculator, that tells me my total area is 2,206.0 meters squared. And my rounding was 1 dp, and that was from previous rounding choices. And again, I've stated my three things. I've got what I'm calculating, I've got my units, and I've got my rounding. So now that I've got my total area, I can actually find out my cost. And the cost in this case will be equal to the area, 2,206, and we're going to times that by the $3.80 that we get charged per meter squared. That's the camping fee that we were talking about earlier on. And this gets us to $8,382.80, so about $8,000. And because this is less than that $9,000 number, we know that these guys are within their $9,000 budget. So this means our conclusion. So the total cost, so this is when we write it in a sentence, the total cost of rates for white Rover camping is $8,382.80, which is less than our $9,000 budget. Therefore, they are within their budget. There we go. So that wraps up the first part, task 1 of our task. So if you were able to find the area and the cost, which we've got in 8 and 9, and you are then able to explain what that meant in a wordy sentence, that there was enough to get you merit. If you didn't get those correct, if you showed me 2 skills, being the triangle rule or the sine rule or the cosine rule, that was enough to kind of make sure your achieved was received. We are now on to task 2, which is the excellence part of this question. And the diagram that was drawn in the question wasn't super clear, but just to clarify, we had our sector, and the angle was unknown, and the radius of the sector was 14 meters. So that was just to clarify. And what's important is basically this sector is being added on to the diagram in part 1. So we need to consider the area from the previous question, which we've got here, and we need to see how the addition will contribute to the total cost of this here. So the first step that I did in this question here was I calculated the maximum area that the diagram in task 1 could be and our new sector could be. So the maximum area, that related to the $9,000, that was our budget, and we divided that by 3.8, which was the cost per meter squared. And based on that, we have a number 2,368 oh gosh, I got that wrong, 68.4 meters squared. And I do want to note, I rounded that down. That's important because if I round up, I actually would have been slightly above that $9,000 mark, and that had a 1 dp rounding. So what that means is if the area of diagram 1, the sector, diagram 1, the original campground, plus the new sector, they've got to be combined, that number or less, to make sure they are still meeting their $9,000 budget. So step number 2, I already know part of the area, so that means the leftover area is going to relate to the maximum area of the sector. So what we need to do is we need to find or calculate the remaining area for the sector. Remaining area for the sector. And we do that by going the total we just have, which is the absolute maximum. We can't have anything more than that. So that's 2,368.4. And I'm going to minus the previous area, 2,206. And when I do that, that gets me to 162.4 meters squared. So my sector cannot be more than that. So my sector, if I really wanted to maximize it, needs to be that exact number. So now that I've done that, step number 3 is I need to use a bit of algebra to help me figure out the unknown angle, which will allow us to have the sector at that particular area. So I'm going to start by writing down my sector formula. So my area is equal to pi r squared, which don't forget is the area of a circle, and I'm going to multiply it by the angle over 360 degrees, and that tells me how much of the circle I actually have. My area, I've already said, is going to be equal to 162.4, so I'm going to jot that down. So 162.4 will be equal to pi times r squared. R relates to the radius of my sector, which is 14. So that's going to be times 14 squared, and we're going to go times pi, or times the unknown angle, over 360 degrees. Now, I've just got one variable, which is the unknown angle. I'm just going to use some algebra to work backwards to find that out. So I'm going to start by going times 360 times 360, and that will cancel out the division. And that got me to quite a big number, 58,464, and that will be equal to pi times 14 squared times the angle. And the pi times 14 squared is just multiplication, so I'm going to move it to the other side as division. So we've got 58,464 divided by pi times 14 squared. So that multiplication is now that division. And that there is going to be equal to the angle because everything else is gone. So putting this on my calculator, I'm going to get the angle. So my angle is equal to 95 degrees, which had a 0 dp rounding. So again, I've stated that I'm trying to find the angle. I've got my units and I've stated my rounding. So that theme again. And the very last step, so this is step number 4, I need to explain or say what exactly I've calculated. What recommendation do I need? So jotting that down, so the sector in diagram 2 must not have an angle exceeding, so must not have an angle exceeding 95 degrees, which is that number we just calculated. So if the angle exceeds that degrees, that means the total area will exceed the amount we've calculated, which means we will exceed our $9,000 budget, and that's not how budgets work. We need to normally stay below it. So I therefore, so just making a conclusion, I therefore suggest the angle be 95 degrees. And that wraps up that question there. So if you were able to use algebra and other procedures to find the 95-degree number and explain what that means, you were then going to be awarded the overall excellence. So I was able to do that in half an hour. In our exam, I think we get an hour. So hopefully that'll give you enough time to navigate through what can be quite a tricky question. And then just a reminder, if you have an absolute nightmare, your full fail proof is for achieved, you must show 2 different skills. Think of the cosine rule, the sine rule, and the area. So thanks so much for watching. Hopefully you found this explanation of our practice internal useful. Now let's keep practicing.